पल हंसना,
एक पल रोना,
दिल का रिश्ता
समझे कौन।
हवा भी जैसे साथ चली थी,
अब तन्हा सा लगे ये झोंका क्यों।
एक पल मिलना,
एक पल खोना,
प्यार का रास्ता
पूछे कौन।
निगाहों में तेरे सपने थे,
फिर इन आँखों में आया धूप कौन।
पल दो पल का साथ ही सही, दिल ने तो तुम्हें अपना माना।
चंद से रोशन था ये पल, अब रातों का ना कोई ठिकाना।
चलती रहे जिंदगी तेरी मेरी, किस्मत ने लिखी है दूरियां।
सपनों की रातों में आज भी महके तेरी ही बातें पुरानियां।
सपने तो हमने साथ बुने थे, पर लम्हों ने हमको रोका।
तुम मुस्कुरा कर दूर चली गई, और दिल मेरा चुपचाप टूटा।
हाँ, दिल के पन्नों पे अब तक लिखा तुम्हारे नाम का हल्का सा नूर।
एक पल हंसना, एक पल रोना, प्यार रहा हम दोनों का जरूर।
एक पल हंसना,
एक पल रोना,
दिल का फंसना कोई न जाने।
तुम भी यादों में, हम भी यादों में, फिर भी लगता है दिल है कोने।
Briefly, our third project, which is a quantitative value strategy. So that's kind of a 30,000-foot view of what you're going to be learning in this course. Let's zoom in a little bit and talk about some algorithmic trading basics. So, for
कभी खुशियों की सरगम लिखेंगे, कभी आंसू की लहरों को रोक लेंगे। जो थामी थी सांसें पल भर को, वो लम्हे फिर से जी कर देखेंगे।
दिलों के तार जो टूट गए थे, आज उनको हम फिर से जोड़ेंगे। कभी खुशियों की सरगम लिखेंगे, कभी खुशियों की सरगम लिखेंगे।
कभी महफिल में जुगनू सा चमक कर, मैं तेरी राहों को रोशन कर दूं। कभी छुप कर तेरी धड़कनों में, मैं खुद को तेरे हवाले कर दूं।
जो सपने हमने अधूरे छोड़े, मैं उन्हें फिर से सजा के ला दूं। कभी मीठी सी पायल की धुन में, मैं तेरे दिल से
मंजिल के मोड़ पे आकर मैं हाथों में तेरा हाथ रख दूं, कभी दुनिया की भीड़ में खुद को तेरी बाहों में छुपा के रख दूं।
जो दर्द हमें डराता रहा है, मैं उस दर्द को हंस कर सह लूं। कभी सपनों की परछाइयों में मैं तेरे लिए एक घर कह दूं।
कभी खुशियों की सरगम लिखेंगे, कभी जिंदगी का नगमा छेड़ेंगे। जो बिछड़ गए रास्ते थे कब के, उन्हें फिर से हम साथ में देखेंगे।
कभी खुशियों की सरगम लिखेंगे, कभी प्यार का पहलू छोड़ेंगे नहीं। दिल से दिल की बातें करते होंगे, हम कल का सपना टूटने नहीं देंगे।
जो गुमसुम सा मौसम था कल तक,
आज बाहों में रंगों सा लगता है।
न जाने कैसे न जाने क्यों, फिर से ये दिल एक नगमा सा लगता है। कभी खुशियों की सरगम लिखेंगे, कभी यादों का गीत सुनाएंगे। ये दिल की दुनिया रोशन होगी जब हम फिर से मुस्कुराएंगे।
कभी खुशियों की सरगम लिखेंगे,
ओ सरगम लिखेंगे।
सरगम लिखेंगे।
For quantitative finance, but it's also a slow language. So a lot of coding languages that are faster. So now let's quickly talk
जिसे ख्वाबों में मैंने छू लिया था, जिसके लिए मैंने हर लम्हा खुद को ही भूला दिया था। तू ही मेरी सांसों का गीत, तू ही मेरी धड़कन का राज। दिल के कोने कोने में बस तेरा ही एक आगाज। अभी मेरी पलकों पे तेरा ही नूर सा छाया है। तू दूर सही पर दिल ने तुझको पास ही पाया है। तू वही है जिसे दिल ने सजाया था। तू वही है जिसे रब से मांगा था।
projects we'll be building. Now, just to quickly summarize, there's three major ways that this course will be different. The first is that we'll be using random data. The data provider that we're using for this course, which is IEX Cloud, is a paid API. So if you want to use real data, you can follow the steps in this course, but actually pay for an account and use a real API token. What we'll be using instead is we will be using a sandbox API token, which provides random data, but it's also free. So what that means is you can do all of the normal things that you can with the IEX Cloud API, but the data will be randomly generated. So you may see some interesting results because of that. The second thing that is different is that we will not actually be executing trades in this course. Now, the reason why that is because many of the people who take this course will be using different custodians to execute their trades. and each one of those custodians will have a different API infrastructure. So I wanted to make this course as widely applicable as possible. So what we're going to be doing instead is we're going to be imagining that we work at a firm where our traders expect us to generate Excel documents and send them to execute trades. So the output of each of these 3 strategies will be an Excel document that has the name of each companies that need to be purchased and the number of shares of each one of those companies that the trader needs to purchase. So we won't be executing trades, but instead we will be generating order sheets to send to our imaginary traders further down the line. And just to reiterate that second point, we're going to be saving these recommended trades to Excel files, which could then be sent to the traders afterwards. All right, so now that we have a bit of a high-level understanding of the algorithmic trading landscape, it's time to talk about API basics and course configuration. So to start, let's discuss what is an API. API is an application programming interface, and you probably are familiar with that if you've ever heard the term API before, but that doesn't actually tell you what it does. I think the easiest way to understand what an API is it's a way for your software to interact with and potentially control someone else's software. So in this case, we're going to be using the IEX Cloud API, and what we're going to do is use their API to access their database of financial data and import it into our Python script. So, like I said, APIs allow you to interact with someone else's software using your own code. And in this course, we're going to be using the IEX Cloud API to gather stock market data to make investment decisions. And to provide you a quick example of what that looks like, here's a code snippet. So this is a cell from a Jupyter notebook that has 4 lines. You can see on the first line that we declare a symbol AAPL, and that is the stock symbol for Apple on the NASDAQ exchange. On the second line, we're creating a string called API URL that has some interpolated values that interpolate in the symbol and our IEX Cloud API token. And then on the third line, we're using the requests library of Python to provide a GET request to that API URL. And then on the last line, we're just printing the data that gets returned. Now, this is kind of a lot, and if you don't fully understand this, not to worry, you'll see this in a lot more detail when we actually build the projects for this course. So that's kind of what an API call looks like. And broadly speaking, in this course, we're only going to be using GET requests to gather data from the IEX Cloud API. Now, if you've never used an API before, there's many different ways you can interact with them, but there's 4 major ones. And I'm going to show you briefly some of the other ways to interact with an API right now before we proceed through this course. So GET requests allow you to get data from the API, and that's what we'll be using in this course. An alternative is a POST request, and that is a method for adding data to the database that's exposed by the API. So a GET request allows you to get data from the API, and a POST request allows you to push data to the API. A PUT request allows you to add and overwrite data in the database that's exposed by the API. Now you can think of a POST request as a create-only request, and you can think of a PUT request as a create or replace request. So there's a slight difference there, and but even though it's a small difference, it's an important difference because that's kind of a common source of bugs for software developers. And the 4th kind of important type of API call is a delete, which, as its name implies, it deletes data from the API's database. So to provide a quick summary of this section, we're going to be using exclusively GET requests in our course, but there's 3 other main types of requests that you should understand, and those are POST, PUT, and delete. Now, like most software concepts, APIs are best learned through rigorous practice. Because of that, here is a URL that you can use to get a long list of public APIs that are great practice for you to interact with APIs. Now, I would probably recommend, if you've never used an API before, to proceed through this course. That will give you a base, fundamental understanding of how to work with APIs. And then once that course is done, you can go to this public URL and practice with some other APIs that are of interest to you personally. So this is not something for you to look at right now, but it's a good resource for you to hit later on. All right, so now that you have a high-level understanding of the course configuration and some API basics, let's move on to talking about our equal weight S&P 500 fund. So if you've never heard of it before, the S&P 500 is the world's most popular stock market index, and many investment funds are benchmarked to the S&P 500. That means that they seek to replicate the performance of this index by owning all of the stocks that are held in the index. Now, if you've never really researched how stocks are added to the S&P 500, there's a committee process and some sophistication there, but the easiest way to understand it is that the S&P 500 broadly covers the 500 largest companies in the United States. So if you own the S&P 500 index fund, you basically own the 500 largest companies in the US. Now, aside from the fact that it owns the 500 largest companies, one of the other most important characteristics of the S&P 500 is that it is market capitalization weighted. Now, Market capitalization is just a finance term that means basically size. So a company with a large market capitalization just means that it's a large company. And what this means is that larger companies get a correspondingly larger weight in the S&P 500 index. For the first project of this course, we're going to build an alternative version of the S&P 500 index fund that assigns the same weight to each company in the index. So instead of Apple having a very big weight and Best Buy having a small weight, every company will have the same weight. So that's going to be the first project of this course. In the second project, we are going to build a quantitative momentum screener. Now, momentum investing means investing in assets that have increased in price the most. To help you understand, let's kind of go through a quick example. Imagine that you have the choice between investing in two stocks that have had the following returns over the last year. Apple stock has gone up 35% and Microsoft stock has gone up 20%. A momentum investing strategy would suggest investing in Apple because of its higher recent price return. There are many other nuances to momentum strategies, including the concept of high quality momentum, and that basically means all else being equal, you would want a stock that has steadily increasing price rather than no price change for a while and then a large jump at the end. But we'll explore those when we actually build our quantitative momentum strategy later in this course. The third project we're going to build is a quantitative value screener. Now, value investing just means investing in stocks that are trading below their perceived intrinsic value. So if you kind of want to make a very simple analogy, value investing is kind of the idea of buying $1 for 75 cents and hoping that you can sell it again for $1 later. So value investing is a very popular investing strategy because many of the world's best historical investors like Warren Buffett, Seth Klarman, and Benjamin Graham have employed this strategy. Creating algorithmic trading investing strategies relies on a concept called multiples, and multiples are simply a way that investors use to estimate how valuable a company is. So to be more specific, multiples are calculated by dividing a company's stock price by some measures of the company's worth, like earnings or assets. So 3 examples of multiples that are used in value investing are the price to earnings ratio, the price to book ratio, and the price to free cash flow ratio. Now, as their name implies, the price to earnings ratio is calculated by dividing a company's stock price by its earnings per share. The price to book value ratio is calculated by dividing a company's stock price by its book value per share. And the price to free cash flow ratio is calculated by dividing a company's stock price by its free cash flow per share. So lots of different ways you can calculate multiples, but those are kind of the three of the most important ones anyway. Now, each of the individual multiples used by value investors has its pros and cons. One way to minimize the impact of any specific multiple is by using what's called a composite. Now, a composite is just an average of many different valuation strategies. So in our strategy that we build in this course, we're actually using a composite of 5 different value investing metrics. Now, with all that out of the way, you have a solid understanding of what we're going to be doing in this course, and it's time for us to dig into the first project. So without further ado, let's do just that. All right, so it's now time for us to start tackling our first project. If you've skipped ahead to this section of this course, there's a couple of things that you should do before proceeding. So the first is to rewind back to the last section and install all of your dependencies. If you're a pretty experienced Python developer, the main dependencies for this course are NumPy, Pandas, and XLSX Writer. So if you already have those on your machine, that's fine. If you've already been following throughout this video so far, I'm in our algorithmic trading Python folder that we cloned to our local computer. I have my virtual environment activated, and what I'm going to do now is launch the Jupyter Notebook for our first project. So to do that, the command is python-m and then notebook. So this should open up a browser window, and what we want to do is navigate into the starter files folder of the algorithmic trading repository, and then open up the equal weight S&P 500.ipymb notebook. It should look like this. So basically, this is what we're going to be working through in this video. It has some instructions written in Markdown and some blank code cells, and that's what we're going to complete as we work through this section. So let's start with just some background information. What we're going to do in this project is to build an equal weight version of the S&P 500 index fund. The S&P 500 is an equal weight, or not an equal weight, a market cap weighted basket of the 500 largest companies in the United States. Interestingly enough, it actually has more than 500 stocks in it because 5 or so of the largest companies in the US actually have multiple share classes. So an example of that is Google. It has a Class A and a Class C share that trade on the stock exchange. So since Alphabet, the company, is included in the S&P 500, both of its stocks are, and because of that, there's usually around 505 stocks in the S&P 500, despite the index only representing 500 companies. So What we're going to do now is create a different version of the S&P 500 index fund that doesn't weight stocks in the index by market capitalization, but instead equal weights them. So what this means is that
दिल का फसना कोई न जोने
तुम भी यादों में हम भी यादों में फिर भी लगता है दिल है
commonly known as the ticker SPY, which
Traders
is the ticker
never
that trades
ever
on the
use
stock
stop
exchange.
loss.
And that
जी
ETF
हाँ,
has
आपने
more
बिल्कुल
than
सही सुना. And that
$250 billion of assets under management, which is pretty crazy. Most asset management firms don't have that much AUM.
पता नहीं कब से
A really big fund to be sure.
तुम्हारी यादें
And
मेरी
so here to go over
सांसों का
section
हिस्सा
report,
बन
create a
गई
Python
है.
script that will accept the values of the and tell you how many shares of each S&P 500 constituent that you need to purchase to get a equal weight version of the index. So the first thing we need to do is, like most Python scripts, this project will rely on
तेरी चाहत में दिल ये खो गया हर धड़कन तुझसे ही जुड़ गया रातों को नींद नहीं आती है तेरा नाम लबों पे ठहर गया
और अगर
So
ये
the first
चाहत
library
एक
we're
ख्वाब
going to import is
हो
NumPy, and the command to
तो
do
वो
that is
ख्वाब
import
भी
NumPy
तुझसे ही सजे मेरी
NumPy
हर
as
दुआ में
NP.
तू ही
Now,
बसे.
NumPy is a
तेरी बाहों
numerical
की वो
computing
नरमी
library, and it's known
मेरी
for its
तन्हाई
fast
को चुपके से छुए.
And the reason why NumPy is so fast is because it's actually a C or
तेरे
maybe C++
बिना ये
module.
मौसम
So when you
अधूरा
call the Python
चांद
function
भी
NumPy,
लगता
it
है
actually
रूठा
executes
रूठा
different programming in that programming.
तेरी नजरों की वो शरारत दिल को करे मदहोश चुप चुप सा
कभी सोचा नहीं था कि कोई यूं मेरी जिंदगी बन जाएगा.
और मैंने कि किसी का इंतजार इतना खूबसूरत हो सकता है
तेरी चाहत में दिल ये खो गया हर एहसास तुझसे ही जुड़ गया जो लिखा था किस्मत की लकीरों में वो नाम बस तेरा ही बन गया.
साजों में घुली है तेरी खुशबू गीतों में बसी है तेरी बातें जब भी पलटूं यादों के कहने मुस्कुराती है वो मुलाकातें
तेरी चाहत में दिल ये खो गया सदियों का रिश्ता जैसे जुड़ गया इस प्यार की नरमी में जन्म मेरा हर सपना सच हो गया
तो फिर ये चाहत कभी खत्म मत होने देना
जब तक ये धड़कन है
calling functions from these libraries. So an example would be let's just run this in the code cell. We want to create a data frame that we'll just create if we had just imported pandas and imported it as a we'd have to write pandas and this call is class by instantiation. Now, because we imported it under the alias PD, we can just PD.dataFrame, and it's a little bit more readable and faster to type. So it's not necessary to import them under aliases. I know a few developers who just run pandas.dataFrame.
कुछ रिश्ते नाम से नहीं एहसास पहचाने जाते हैं
हम तुम्हारे हैं ये दिल जानता है हर धड़कन में तेरा ही फसाना है तेरे बिन ये दुनिया सोनी लगे तू ही मेरा सारा जमाना है
और अगर ये दिल कभी डगमगाया
हो जाती है पता नहीं
तो
कितनी चीजों से एलर्जी है
मेरा हमें
मैंने हाथ पकड़ा
रखना
तभी उसके हाथ बहुत ठंडे थे
हर राह पे साथ निभाना जो भी हो इस दिल की हालत
तेरे संग बीते हर लम्हे सपनों की सेज सजा जाए
बारिश की वो भीगी रातें तेरे नाम ही लिख जाए
generation
मैंने
of Python scripts. So,
खुद
all right,
को
so once
तुमसे
you're on that course,
जाना
all of your
है।
library will be imported, and the next
हम
thing we need to do
तुम्हारे
is to import our list of
उम्र
stocks.
भर
Now,
के
like I said, this is
ये
gonna be a list of
वादा
those 500 stocks.
आज निभाया है।
सांसों में बसी है तेरी खुशबू, दिल ने तुझको अपनाया है।
काजल सी गहरी रातों में तेरी बाहों का उजियारा, जब भी डर से दिल कांपे तेरा नाम बने सहारा।
तुम हो तो हर डर बेकार है,
तेरी हंसी की वो झनकार
जीवन का संगीत बने।
तेरे साथ ये छोटी दुनिया,
हम तुम्हारे हैं बस तुम्हारे, ये सच दिल ने माना है।
इस जन्म से उस जन्म तक
सिर्फ तुझको ही चाहा है।
तो फिर ये प्यार अमर है।
क्योंकि हम तुम्हारे हैं।
P.read CSV and then the name of the file. So if you just type in SP and then tab, it might autocomplete. There it is.
वादा तो
And it doesn't
उम्र भर
autocomplete
का
type
था।
in the file name. So
फिर ये
what is
दूरी
it? It is,
एक
this is a
पल में
method that
क्यों
lives
बन गई?
within the pandas library that takes in data in the form of a CSV and then stores it in the pandas data frame. So you can verify
दिल
that
बता जरा
stocks and this should return pandas data frame.
प्यार का ये सिलसिला क्यों थम गया।
So Jupyter Notebook
क्यों
has
रूठी वो मुस्कान मेरी, जिस पे हर ख्वाब आकर सो गया।
क्यों तोड़ा दिल बता जरा,
क्यों तोड़ा दिल।
That's what we're going to work with for the rest of this tutorial. The next thing we need to do is acquire an API. Like I mentioned in the course, we're going to use the IEX API to gather all the data. And like most APIs, it requires
तेरी बातों में जो सुकून मिला वो किसी और लम्हे में ना था। तेरे हाथों की वो गर्माहट आज भी रगों से जुदा न हुआ।
कभी कभी हालात
randomized financial data.
दिल से
And,
ज्यादा
the reason why
ताकतवर हो
it's
जाते
important
हैं।
is because it allows you to test whether or
मुखड़ा
not,
क्यों तोड़ा दिल बिना खता, क्यों ये रिश्ता अधूरा रह गया, जिसे पूजा था मैंने रब की तरह, वही मुझसे बेगाना हो गया।
रातों ने पूछे मेरे आंसू से, किसकी याद में ये सैलाब है। मैंने बस इतना ही कहा उनसे, ये उसी प्यार का हिसाब है।
सवाद अगर भूलना इतना आसान
You'll
होता
notice in the git ignore of this course,
तो ये दिल
the secrets.py file is
आज भी
actually
यूं
included in the
रोता
git ignore,
क्या?
which means that push your changes out to GitHub, so
टूटे ख्वाबों की ये सदा अब सुनता कौन है भला।
तेरी तस्वीर आज भी देखूं तो वक्त ठहर सा जाता है।
नाम तेरा जब लबों पे आए, दिल खुद से ही टूट जाता है।
सवाद
in my case it says
हमारा साथ इतना ही था,
पर मेरी मोहब्बत तो पूरी थी।
क्यों तोड़ा दिल ए हम सफर, क्या मेरा प्यार कम पड़ गया, जिंदगी भर का जो सपना था वो एक आह में बिखर गया।
क्यों तोड़ा दिल बता जरा,
क्यों तोड़ा दिल।
कुछ दिल सवाल बन जाते हैं जिनका जवाब कभी नहीं मिलता।
Like that when working through this code, and in some courses people edit it out for a more clean experience, but I would say in the majority of things I'm going to leave it in so you can see the debugging process and what I actually do to fix the problems that I encounter. So that was a small example of that. You'll see more as we work through this course. So now we're going to make our first API call. So making API calls is a bit of an art because every API works a little bit differently, and some APIs have in this case
ये हवा कुछ कह रही है,
शायद मौसम भी हमारी कहानी सुनाना चाहता है।
मौसम ये सुहाना है, दिल भी दीवाना है,
हर एक फसाना अब तुझसे ही जुड़ जाना है।
हवाओं की तरह तू रूह में समाना है।
मौसम ये सुहाना है, मौसम ये सुहाना है। धूप ने छुआ जब तेरा चल, चांद भी ठहर कर देखने लगा। तेरी नजरों का जादू ऐसा, हर मौसम मुझ पे उतरने लगा।
सवेरे खोगे तो बारिश भी रुक जाएगी,
सवाल तो रुक जाने दो, बात करने का बहाना मिल जाएगा।
मौसम ये सुहाना है, प्यार का बहाना है,
तेरे बिना इस दिल को कुछ भी न भाना है। बरसात की बूंदों में तेरी हंसी कंगन सी छलकने लगी।
मिट्टी की खुशबू में तेरी यादें सांसों से लिपटने लगी।
क्या हर बारिश ऐसी ही होगी
जब तक तुम साथ हो। प्यार ही है ठिकाना,
शाम ढले तो दीप जले, तेरे नाम की रोशनी,
तेरे संग ही पूरी हो जाऊं मेरी हर अधूरी ही कहानी।
सदियों का ये रिश्ता आज फिर पहचाना है, दिल ने जो चाहा है तू ही तो वो खजाना है।
मौसम ये सुहाना है, मौसम ये सुहाना है,
मौसम ये सुहाना है, मौसम ये सुहाना है।
कुछ मौसम याद बन जाते हैं
और कुछ यादें उम्र भर का मौसम।
Note that IEX Cloud does have this search bar over here in the top left, but for some reason I was just found myself using Control F instead. So what we're going to do here is do market cap, or let's just do market cap, not market capitalization, because it's sometimes abbreviated. So what do we have here for the first is enterprise value and price to sales. So these are both metrics that are calculated using market capitalization. They don't actually give us market capitalization, so neither of those is what we need. The next one is actually a true market cap metric, and this is exactly what we need.
वो सदियों से दिलों में बसे
response
होते
attributes
हैं।
from this API, and
और जब
this doesn't
ऐसे
actually give you
रिश्ते
stop
मिल
price. So we, like I said, we ideally want to find an endpoint that has both price and market cap, and with a bit of searching, you would find that the quote endpoint provides both of those.
मुखियों का ये साथ लगता है आज मिला,
जैसे कोई भूला हुआ ख्वाब हकीकत बन चला।
धड़कनों की हर एक बात कहे, तू ही मेरा कल, तू ही मेरा आज बना।
सदियों का ये साथ, सदियों का ये
This actually won't work because this, curly bracket symbol thing here doesn't mean anything in the context of this string. If we try to execute this HTTP request as it is, this will return it 400 error code. So what we need to do is we need to transform this API URL into an F string. Now, an F string, if you've never used it before, I'll give you a very brief introduction. So if you have string equals free,
नजरों ने जब तुझे देखा पहली बार, जैसे पहचाना हो तुझे जन्मों से।
तेरी बाहों में सिमट आई है डगर, जैसे राहें मिली हो मंजिलों से।
क्या सच में हम पहले भी मिले थे?
अगर मिले नहीं होते तो दिल यूं क्यों मन जाता।
सदियों का ये साथ रुकता नहीं कहीं, तेरे बिना ये दुनिया मेरी नहीं रही।
रातों ने ओढ़ी तेरे नाम की धूप, चांद भी पूछे किसकी हो तुम।
सांसों में बस तेरी हर एक हंसी, मेरी हर दुआ में बस तुम ही तुम।
अगर वक्त ठहर जाए
तो मैं इसी लम्हे में उम्र बिता दूं।
दिल की ये कहानी अनकही,
अंत हमारी अमर सही।
तेरे नाम से शुरू मेरी हर सुबह, तेरे नाम पे ढले मेरी हर शाम।
तेरे संग ही पूरी हो जाऊं मैं, तू ही मेरी पूजा, तू ही मेरा अरमान।
ये मोहब्बत नहीं
तो फिर क्या है?
सदियों का ये साथ टूटे न कभी जन्मों जन्मों तक। लिखिए कहानी सभी वक्त भी सर झुका ले प्यार के आगे। तू ही मेरी दुनिया, तू ही मेरी जमीन।
सदियों का ये साथ, सदियों का ये साथ। प्यार वक्त से बड़ा होता है।
.get method.
और कुछ
Now,
7
if you've never
सदियों
used the
के लिए
request
होते
library,
हैं।
that's what we imported at the top of our script here. It's kind of known as the world's best Python library for executing HTTP requests. Their
जब से तुम
tagline
सामने आई हो,
their tagline is
हर
HTTP
धड़कन
for
कोई
humans,
पुराना
and I quite like that.
संगीत
It does
गाने
describe well what they do. So what we need to do here is just type in request.get and then pass in our API URL.
और
Now, if we run
जब
that,
से तुमने मेरा नाम
what the
लिया है,
heck is this data variable?
ये
The
दिल
easiest way to check is
खुद
to
को
just use
भूल
the type
बैठा है।
function and pass in data. And what it is it's a response object, which is contained within the module of the request library. Now, this response object has many different things inside of it, and one of the more interesting ones is the status code. So we can do print data status code. I'm going to hit tab. Okay, it didn't. Oh, there we go. And this gives us a 404. Now, why the heck does it give us 404? Clearly, I did something wrong here. Okay, so I just figured out the error, and what I missed here was there's an additional kind of suffix that needs to be added to the IX cloud endpoint called /stable. Now, why does that exist? If you
ये
look at the section
कैसा
here,
असर है सनम,
stable or latest. Stable is
खामोश
kind of
दिल
the,
भी
latest
आज
stable
बोलने लगा।
well, latest.
ये
And actually,
कैसा
latest
असर
is
है
stable.
सनम,
So basically, stable is what you want to use if you want
हर
to
सपना मेरा तुझसे जुड़ने लगा।
दिल की हर एक राह पर तेरा ही नाम लिखा है सनम।
Now we get a response 200 error, or a response 200 codec,
सनम,
which means that the
ये कैसा असर है सनम।
status code actually doesn't match this. And the reason I like this better is you can say, you can test the quality operator. So this is 200 true, and that's kind of an easy way to handle exceptions. You can say it's not equal to 200. You could say if it's not equal to 200, then do something. Anyway.
नजरों ने जब से तुझे पहचाना, चांद भी शर्मा के बादलों में छुप गया।
सांसों में घुल गई तेरी धड़कन, हर लम्हा मेरा सुनहरा हो गया।
इतनी जल्दी दिल हार गए जनाब,
It gives us a
हार
long
नहीं,
JSON
इबादत है ये।
kind of
मुखड़ा
Python
सर
dictionary
है
that
सनम,
kind of
हर धड़कने में बस तू ही तू, दिल आज खुद से ही बेखबर, मेरी दुनिया शुरू हो तुझसे ही सनम।
रातों ने ओढ़ी तेरे नाम की चादर, नींद भी पूछे कब आओगे तुम।
बरसों पुराने किसी वादे
This is a
सा,
Python dictionary called dictionary.
दिल में बसे हो हर जगह हो तुम।
अगर वक्त रुक
Here are
सकता
called key value
तो मैं
pairs.
इसी पल
This
में
is
जीना
key, it's
चाहूं।
A, and this is
ब्रिज
the value
बिना
one.
अधूरी सी हर कहानी, तू ही मेरी धड़कनों की निशानी।
तेरी हंसी में सवेरा है, तेरे आंचल में शाम ढली, तेरे साथ ही पूरी हो जाऊं, मेरी हर दुआ तुझसे ही मिली।
सवाद नहीं तो और क्या है,
ये कैसा असर है सनम, वक्त भी ठहराए तेरे संग सनम।
We're gonna parse that.
जिंदगी गाए ये गीत सदा,
Okay,
तू
so
ही शुरुआत तू ही अंजाम सनम।
ये कैसा असर है सनम,
the easiest way to tell it's
ये कैसा असर है सनम।
कुछ एहसास उम्र नहीं देखते,
That's the latest price.
बस दिल में अमर हो जाती है।
Yeah. Now, if you ever see something like this and you say, huh, I don't know what latest price means. That's kind of a bad example, but let's look at something else that is not about it. Alright, this is extended change. Now, what the heck is extended change? Well, it takes a lot of calculations, it should tell you. So, if you you just copy that
कुछ
extended
लोग
change
साथ
string
नहीं
to
होते,
clipboard, and then go back to the IEX Cloud docs.
फिर भी
run
पूरी
a control
जिंदगी
F
बन
search,
जाते
and
हैं।
type in extended change. It will take you not just to this
तू
JSON object,
मेरी
it should be a description below.
जिंदगी
So,
है,
as you can see here, extended change
ये
refers to
दिल
the price
कहता
ranging between extended price. So,
रहा,
without knowing what those two means, this is kind of meaningless, but this was just an
हर
example to show you how you
सांस
can look up
में
the meaning of different
तेरा ही
data
नाम
points within the JSON response. in the
बहता रहा।
Okay, so that's how to parse price. We can print it out
तुझसे
using the
शुरू
price.
तुझ पे ही
Now, I
खत्म
actually
हूँ,
am not sure if the IEX Cloud
तेरे बिना
price
हर
status is random.
सपना अधूरा रहा।
और अगर जिंदगी कभी मुश्किल बन जाए तो
Okay,
तो
so I
मैं
don't
बनूं
think
तेरी
that this price is
हर आसान राह,
so this price tag is random.
तेरे हर गम की बनूं पनाह।
Price and then for
तू
market
थामे
cap,
रखना मेरा विश्वास, मैं थाम लूंगी तेरा हर सांस।
market cap. Awesome. This is like
तेरी नजरों की वो नरमी दिल को चुपचाप छू जाती है, तेरे लबों की खामोशी भी कोई मीठी धुन गुनगुनाती है।
मैंने जीना तुमसे सीखा है,
और मैंने हंसना तुम्हारे साथ।
तू मेरी जिंदगी है, मेरा सुकून, तेरे बिना सब लगता बेनून। जो लिखा था मेरी किस्मत में वो तेरा प्यार बना जुनून।
सिंदूरी सुबह, चांदनी रातें, सब में तेरा ही अक्स दिखे, मेरे हर ख्वाब की तस्वीर में तेरी बाहों का हक दिखे।
अगर ये सपना है तो मैं जागना नहीं चाहता। तेरे साथ जो वक्त मिला, वो दुआ बन के उतरा है। तेरी एक मुस्कान से ही मेरा हर कल सांवरा है।
तू मेरी जिंदगी है, मेरा जहां, इस सच को क्या झुठलाना है। हर जन्म में बस तेरा नाम मेरी रूह ने गुनगुनाना है।
तो फिर ये जिंदगी हमारी हुई,
क्योंकि तू ही मेरी जिंदगी है।
This is kind of what it looks like. There's no data in here right now, so it's kind of empty. But what we can do is just do create a list of a list that's going to be 0, 0, 0, 0.
क्या लोग
And this is kind of how pandas data frames typically render. So one of the
पता
advantages
नहीं
of
कब
not
से
using a formal print statement is that when you just list the
तुम्हारी
data
यादें
frame,
मेरी सांसों का हिस्सा बन गई हैं।
render in this nice format that kind of allows you to mouse over it and change color. It's just a little bit nicer to look at than the alternative. If you use a print statement, it'll print like this. So that's what plain text. Actually, I'm not a big fan of it. So we'll stick with data frames specifically like this. So that's what our data frame looks like. I'm going to get rid of this line of zeros because that was just the render. And that's what we're going to be working with moving forward. So what we're going to do now is I'm going to show you how to append
तेरी चाहत में
to
दिल ये खो गया,
what we're going to use
हर धड़कन तुझसे ही जुड़ गया, रातों को नींद नहीं आती है, तेरा नाम लबों पे ठहर गया।
और अगर ये चाहते ख्वाब हो तो वो ख्वाब भी तुझसे ही सजे, मेरी हर दुआ में तू ही बसे, तेरी बाहों की वो नरमी मेरी तन्हाई को चुपके से छुए, तेरे बिना ये मौसम अधूरा, चांद भी लगता है रूठा रूठा, तेरी नजरों की वो शरारत दिल को करे मदहोश, चुप चुप सा।
कभी सोचा नहीं था कि कोई यूं मेरी जिंदगी बन जाएगा,
और मैंने कि किसी का इंतजार इतना खूबसूरत हो सकता है।
तेरी चाहत में दिल ये खो गया, हर एहसास तुझसे ही जुड़ गया, जो लिखा था किस्मत की लकीरों में वो नाम बस तेरा ही बन गया।
साजों में घुली है तेरी खुशबू, गीतों में बसी है तेरी बातें,
जब भी कर दूं यादों के पन्ने, मुस्कुराती है वो मुलाकातें।
अगर वक्त रुक सकता तो मैं हर लम्हा तुम्हारे साथ जीना चाहता,
तेरे संग बीते हर पल को मैं उम्र भर संभाल के रखूं, दुनिया चाहे जो भी कह ले मैं बस तुझसे ही प्यार लिखूं।
तेरी चाहत में दिल ये खो गया, सदियों का रिश्ता जैसे जुड़ गया, इस प्यार की नरमी में जानम मेरा हर सपना सच हो गया।
तो फिर ये चाहत कभी खत्म मत होने देना, जब तक ये धड़कन है तब तक नहीं।
final data frames on the pen method, and then within that final data frames on the pen method, we created a pandas series that has all of the data points we wanted, and then we specified index equals my columns, which tells the append method which columns to add this data to, and then lastly we added which kind of Alright, so what we need to do now is move through every ticker in our stock series and execute an API call for that stock and then store
कुछ
the
रिश्ते नाम से नहीं,
So to start, we're going to overwrite our old pandas data frame
एहसास से पहचाने जाते हैं।
that has the same column before, so column equals my. Then we need to create a
हम तुम्हारे हैं ये दिल जानता है, हर धड़कन में तेरा ही फसाना है।
तेरे बिन ये दुनिया सुनी लगे, तू ही मेरा सारा ज़माना है।
डर अगर
we need to actually
ये दिल कभी डगमगाया था,
so to do
तो
that,
मेरा हाथ थामे रखना,
and we're going to copy both
हर राह पे साथ निभाना।
जो भी हो इस दिल की हालत,
needs to get indented.
बस मुझसे यूं ही बतलाना।
Our IDX API code is the same, that is the same. So that's all good. Now, one thing to note about moving through our list of stocks in this way is that it's going to be really, really slow. And the reason
बारिश की वो भीगी रातें तेरे नाम ही लिख जाए।
मैंने खुद को तुम में पाया है
और मैंने खुद को तुमसे जाना है।
हम तुम्हारे हैं उम्र भर के ये वादा आज निभाया है। सांसों में बसी है तेरी खुशबू दिल ने तुझको अपनाया है।
काजल सी गहरी रातों में तेरी बाहों का उजियारा जब भी डर से दिल कांपे तेरा नाम बने सहारा।
तुम हो तो हर डर बेकार है
तेरी हंसी की वो झनकार जीवन का संगीत बने।
तेरे साथ ये छोटी दुनिया मेरा पूरा जहां बने।
हम तुम्हारे हैं बस तुम्हारे ये सच दिल ने माना है।
इस जन्म से उस जन्म तक सिर्फ तुझको ही चाहा है।
तो फिर ये प्यार अमर है।
क्योंकि हम तुम्हारे हैं।
This is for the first 5 stalls. If we take off this little argument here, this will take a very long time to run. Let's just see that in here. Alright, so as you can see, this is a very long data frame that has all the information we needed. Since it took so long, we're going to move on now to the batch API calls to improve the performance of this code. Now, IEX Cloud, like most data providers, actually gives you discounts if you use batch API calls to load other infrastructure. So that's one reason to use it. The fact that you get the code is overall, batch API
क्यों रूठी वो मुस्कान मेरी जिस पे हर ख्वाब आकर सो गया।
क्यों तोड़ा दिल बता जरा क्यों तोड़ा दिल।
तेरी बातों में जो सुकून मिला वो किसी और लम्हे में न था। तेरे हाथों की वो गर्माहट आज भी रगों से जुदा ना हुआ।
कभी कभी हालात दिल से ज्यादा तत्वर हो जाते हैं।
क्यों तोड़ा दिल बिना खाता क्यों ये रिश्ता अधूरा रह गया।
जिसे पूजा था मैंने रब की तरह वो ही मुझसे बेगाना हो गया।
रातों ने पूछे मेरे आंसू से किसकी याद में ये सैलाब है। मैंने बस इतना ही कहा उनसे ये उसी प्यार का हिसाब है।
सवाद हवाला सा खेत में ही था तो ये दिल आज भी रोता क्या।
This is from index 0 to index 199.
टूटे ख्वाबों की ये सदा अब सुनता कौन है भला। जब लबों पे आए दिल खुद से ही टूट जाता है।
शायद हमारा साथ इतना ही था,
पर मेरी मोहब्बत तो पूरी थी।
क्यों तोड़ा दिल है हम सफर, क्या मेरा प्यार कम पड़ गया।
जिंदगी भर का जो सपना था वो एक आह में बिखर गया।
क्यों तोड़ा दिल बता जरा,
क्यों तोड़ा दिल।
कुछ दिल सवाल बन जाते हैं जिनका जवाब कभी नहीं मिलता।
So what we need to do is use the append method to add these in. So we're going to do symbol strings dot append, and then what we're going to use is the join method called on the comment measure. Now,
सवाद
if you've never used the join method before, basically what this does is
मौसम भी हमारी कहानी सुनाना चाहता
and
है।
join them together by separating them with this. So to see that in action,
मौसम ये सुहाना है,
symbol strings.
दिल भी दीवाना है।
All right, so here's one example.
हर एक फसाना अब तुझसे ही जुड़ जाना है।
हवाओं की तरह तू रूह में समाना है। मौसम ये सुहाना है, मौसम ये सुहाना है।
Print that to make sure that it looks okay. Awesome. So we can delete.
धूप ने छुआ जब तेरा चल, चांद भी ठहर कर देखने लगा।
तेरी नज़रों का जादू ऐसा, हर मौसम मुझ पे उतरने लगा।
सवाद से जो खोगे तो बारिश भी रुक जाएगी।
सवाद से देखोगे तो बारिश भी रुक जाएगी।
तो रुक जाने दो, बात करने का बहाना मिल जाएगा।
मौसम ये सुहाना है, प्यार का बहाना है। तेरे बिना इस दिल को कुछ भी ना भाना है।
बरसात की बूंदों में तेरी हंसी कंगन सी छनकने लगी।
मिट्टी की खुशबू में तेरी यादें सांसों से लिपटने लगी।
क्या हर बारिश ऐसी ही होगी?
सवाद जब तक तुम साथ हो।
दिल ने आज ये जाना, प्यार ही है ठिकाना।
शाम ढले तो दीप जले तेरे नाम की रोशनी।
तेरे संग ही पूरी हो जाऊं मेरी हर अधूरी कहानी।
ये लम्हा यूं ही ठहर जाए।
मौसम ये सुहाना है,
वक्त भी दीवाना है।
सदियों का ये रिश्ता आज फिर पहचाना है।
दिल ने जो चाहा है तू ही तो वो खजाना है। मौसम ये सुहाना है,
मौसम
ये सुहाना है।
कुछ मौसम
So the first thing we're
याद
going
बन
to do is
जाते
remove
हैं।
this last parameter and this
और
range
कुछ
parameter.
यादें उम्र
We
भर
don't
का
need
मौसम।
the API call that we're doing. The next thing we're going to do is remove the chart and news endpoint. We don't need them. Next, we're going to actually remove the symbols that are hard-coded into this. We're going to do a variable interpolation for symbol string. And then what we're going to do is move to the very end. And as before, we can just copy on the IEX Cloud API code that we had in our original API code. Copy this, scroll back down, go to the end of the string, and add it. Awesome. Now, let's just do for symbol string and symbol string up to, but not including the first
और
one.
जब
And then we're going to just
ऐसे
print it
रिश्ते
into
मिल जाए तो वक्त भी हार
and I
मान
spelled
लेता
that
है।
here, which I'm going to correct now.
मुखरों का ये सा लगता है आज मिला,
जैसे कोई भूला हुआ ख्वाब हकीकत बन चला।
धड़कनों की हर एक बात कहे तू ही मेरा कल, तू ही मेरा आज बना।
सदियों का ये साथ, सदियों का ये साथ।
नजरों ने जब तुझे देखा पहली बार, जैसे पहचाना हो तुझे जन्मों से।
तेरी बाहों में सिमट आई हर डगर, जैसे राहें मिली हो मंजिलों से।
क्या सच में हम पहले भी मिले थे?
अगर मिले नहीं होते तो दिल यूं क्यों मान जाता।
सदियों का ये साथ रुकता नहीं कहीं, तेरे बिना ये दुनिया मेरी नहीं रही।
रातों ने ओढ़ी तेरे नाम की धूप, चांद भी पूछे किसकी हो तुम।
सांसों में बसी तेरी हर एक हंसी, मेरी हर दुआ में बस तुम ही तुम।
सवाद वक्त ठहर जाए तो मेरे सी लम्हे में उम्र बिता दूं।
दिल की ये कहानियां कही, प्रीत हमारी अमर सही।
तेरे नाम से शुरू मेरी हर सुबह, तेरे नाम पे ढले मेरी हर शाम।
तेरे संग ही पूरी हो जाऊं मैं, तू ही मेरी पूजा, तू ही मेरा अरमान।
ये मोहब्बत नहीं तो फिर क्या है?
सदियों का ये साथ टूटे ना कभी, जन्मों जन्मों तक लिखिए कहानी सभी।
वक्त भी सर झुका ले प्यार के आगे, तू ही मेरी दुनिया, तू ही मेरी ज़मीन।
सदियों का ये साथ,
सदियों का ये साथ। वक्त से बड़ा होता है।
जब से तुम सामने आई हो, हर धड़कन कोई पुराना सा गीत गाने लगी है।
संवाद मुस्कुराती हुई,
और जब से तुमने मेरा नाम लिया है, ये दिल खुद को भूल बैठा है।
सपना मेरा तुझसे जुड़ने लगा।
दिल की हर एक राह पर तेरा ही नाम लिखा है सनम।
ये कैसा असर है सनम,
ये कैसा असर है सनम।
नजरों ने जब से तुझे पहचाना, चांद भी शर्मा के बादलों में छुप गया।
सांसों में घुल गई तेरी धड़कन, हर लम्हा मेरा सुनहरा हो गया।
इतनी जल्दी दिल हार गए जना,
हार नहीं इबादत है
ये कैसा असर है सनम। हर धड़कन में बस तू ही तू,
आज खुद से ही बेखबर, मेरी दुनिया शुरू तुझसे ही सनम।
रातों ने ओढ़ी तेरे नाम की चादर, नींद भी पूछे कब आओगे तुम।
बरसों पुराने किसी वादे सा, दिल में बसे हो हर जन्म हो तुम।
अगर वक्त रुक सकता
तो मैं इसी पल में जीना चाहूँ। तेरे बिना अधूरी सी हर कहानी, तू ही मेरी धड़कनों की निशानी।
तेरी हंसी में सवेरा है, तेरे आंचल में शाम ढली।
तेरे साथ ही पूरी हो जाऊं, मेरी हर दुआ तुझसे ही मिली।
स्नो हवा तो नहीं तो और क्या है,
ये कैसा असर है सनम।
वक्त भी ठहर जाए तेरे संग सनम। जिंदगी गाए ये गीत सदा, तू ही शुरुआत,
तू ही अंजाम सनम। ये कैसा असर है सनम, ये कैसा असर है सनम।
कुछ एहसास उम्र नहीं देखते,
What we're gonna do is put that in here and say
बस दिल में अमर हो जाते हैं।
and then for this except we're going to say please insert. Now if we put in a sentence, we'll say again I don't have a portfolio. It returns please enter an integer. Now this broad try except statement is actually not good, and the reason why is because this will react regardless of what type of error is happening. So what we need to do to make sure that it only handles the specific type of error that we're trying to address,
कुछ लोग साथ नहीं
we need
होते,
to try to do this
फिर भी पूरी जिंदगी बन जाते।
kind of force an error. So let's put a string in there, and then as you can see, the type of error that's created is a value error. So we need to basically
ये
change
दिल
this string
कहता
so that it
रहा,
only reacts to value errors instead of reacting to all types of errors.
हर
And the way that
सांस
you do
में
that is
तेरा ही
put the
नाम
type of error right here.
बहता रहा, तुझसे शुरू तुझ पे ही खत्म हूँ।
Handling this
तेरे बिना हर सपना अधूरा रहा।
redo this.
और अगर
So,
जिंदगी कभी मुश्किल बन जाए
how does this look?
तो मैं बनूं तेरी हर आशान राह, तेरे
what
हर
we'll do
गम
is
की
say
बनू
in
पना
here,
तू थामे रखना मेरा विश्वास मैं थाम लूंगी
exactly why we're
तेरा हर साथ
that's
तेरी नजरों की वो नरमी दिल को चुपचाप छू जाती है तेरे लबों की खामोशी भी कोई मीठी धुन गुनगुनाती है
मैंने जीना
the first step
तुमसे
of the
सीखा है
block, we
और मैंने
try to
हंसना
force
तुम्हारे
that,
साथ
that input value to be if that doesn't work, if the value then we print here, that's not enough, let's please try again. And then we drop the input value again. And then we force it to be a stronger than float again. Now, one interesting thing to note about this is that if you do it twice, string and then string, it will still
मैंने
print the
जीना
value. So
तुमसे सीखा है
और मैंने हंसना तुम्हारे साथ
तू मेरी जिंदगी है मेरा सुकून
तेरे बिना सब लगता बेनून
जो लिखा था मेरी किस्मत में वो तेरा बना जुनून
अगर ये सपना है तो मैं जागना नहीं चाहता
तेरे साथ जो वक्त मिला वो दुआ बन के उतरा है तेरी एक मुस्कान से ही मेरा हर कल सवरा है
तू मेरी जिंदगी है मेरा जहां इस सच को क्या झुठलाना है हर जन्म में बस तेरा नाम मेरी रूह ने गुनगुनाना है
Now saying invest, $19,000.
तो फिर ये जिंदगी हमारी हुई
Hang on, is this a million or
हाँ
1, 2, 3? That's 10
क्योंकि
million.
तू ही मेरी जिंदगी
$19,000
है
each stock, or almost 20,000 makes sense for a $10 million portfolio. All right, so we have the position size now. Now we need to calculate how many shares of each stock need to be purchased to get to that position size in that stock. So let's take an easy example. Apple's stock price is about $500 right now. So if we wanted, number of Apple shares to buy, you would just say position size divided by Apple stock price, which is $500-ish, and then you can print the number of Apple shares. And in this case, it says, okay, buy 39.6 Apple shares. Now, this introduces an interesting concept in that a lot of places do not support fractional trading, which means that you can't buy a portion of a share. You can only buy whole shares. So you can buy 39 shares or you can buy 40 shares, but you cannot buy 39.6 shares. So how do we handle this? Well, it's tempting to just say, let's round it to the closest number, up or down. But what might happen then is that if you are rounding up more integers than you're rounding down, you'll actually end up buying more stock than you have money for, and that is not a good thing. You would get to the end of your allocation and say, oh man, I don't actually have enough money left over to get to my position size target on this stock. So because of that, we actually have to round each of these down, and that's where that math module that we imported earlier comes in. So math.floor is Python's round down function. So if we print this, it should give us 39. Oh shoot, math is not defined. I think it might be lowercase n. Yeah, math.floor. So that gives us 39. Okay, so this is kind of like the logical intuition on how to do this. We now need to programmatically loop through every row of our pandas data frame and actually apply this logic to the number of shares to buy column. Now, to do this, I'm just going to comment that out because it'll be useful for us later. All right, so we're going to say for I in range from 0, and then we needed to go to the last row of the data frame, and the easiest way to do that is to just say the length of any row within the data frame. And what I typically use is final data frame index. As you can see, this logic is actually basically what I used here as well. So let's use this and then just print everything in here. All right, this goes from 0 to 504. Let's just make sure that adds up with the data frame we clicked earlier, or printed earlier, I should say. It goes from 0 to 504. Awesome. Now we need to access this cell in each row of the data frame. The easiest way to do that is using the LOC method. So what we're going to do is say final data frame dot LOC, and this is basically like an easy row column way of accessing data in pandas. So for the row, we're going to say I, and for the column, we're going to say number of shares to buy, and let's just print this to see if it prints a bunch of NAs, because that's what it should print. Awesome, so we're correctly accessing the data. Now we need to actually assign the data. So to do that, you can just use the equality operator and then say math.floor, and then we need to do basically this calculation here, position size divided by the stock price. So we'll say position size divided by. Now, what are we going to do for stock price? Do we have to execute another API call and pull that data from IEX again? We actually don't, and the reason why is because that data is already stored in the pandas data frame. So we can take similar logic to this LOC method here and put that there, paste it, and just change this to stock price. Oh, this tab autocomplete is not working. So if we run this, what happens? It ran correctly. Let's do this again and print the data frame to see if it looks okay. Awesome, so as you can see, it correctly kind of shows the number of shares to buy here. One easy way to fact check this, well, there's a couple things you can do. The first thing is to say, okay, this Apple stock price is close to the 39 that we calculated earlier, so that's a good sign. Another thing you can do is say, look at two stocks that have different stock prices, and the one that has the higher stock price should be recommended to buy less shares than the one that has a lower stock price. So let's just use the first two rows of this data frame as an example. You can see that for this stock with ticker A, it costs $100 to buy it, and you're buying 197. And then the second stock has a much lower stock price, and because of that, you have to buy many more shares to actually reach your target position size. Now, that kind of all looks good, so we can move on. I'm going to take away this commented code and just tidy this up a little bit, and we can proceed to the next cell. All right, so this brings us to the last section of this project, which is to save our pandas data frame into an XLSX file for non-technical users to access through Excel. So the big idea here is that we did all of the work in a Python script. You could schedule this script to run periodically, and then the output would be sent to your trading team to actually buy and sell stocks in response to the output. So to do this, we're going to use the XLSX writer library for Python. Now, oops, I didn't mean to run that. If you remember at the start of this project, many lines of code ago, we actually imported this here, so it's actually in our script already. We just need to use it now to save our data frame as an Excel file. Now, XLSX Writer is an excellent package and offers an insane amount of customization, but the trade-off for this is that the library can seem a bit complex to new users. I'm going to do my best to explain it well throughout this section, and because of that, this might be a bit long, so if this seems easy or you've used if this seems easy or you've used XLSX Writer in the past, you can feel free to speed up the speed here a bit or skip ahead. All right, so the first thing we need to do is actually initialize our XLSX Writer object. And the way that we do that is by saying writer equals pd.xlwriter. And then here we need to pass in the file name that we want to save to. In this case, we're going to do recommended trades.xlsx. And then we need to specify the engine, which is XLSX Writer. Now, let's break this down a little bit to kind of describe what's going on here. As you can see, the class that we're initializing here is from the pandas library and not actually from XLSX Writer. And the reason why that is because since pandas deals with tabular data and so much tabular data is actually saved to Excel files, they have a very tightly coupled integration, and it actually kind of is easiest to initialize a new writer object from pandas rather than XLSX Writer. And kind of by default, you always save these objects to a variable called writer. It allows you to reuse your code without having to change the object name later, and it's kind of just a best practice. So we're going to say writer equals p.xlwriter, and then this is the file name that we want to save to, and then the engine equals XLSX writer. It may seem a bit redundant, but this library can also be used to save XML files, so we have to actually specify that we want to work in Excel. So that's the first thing we need to do. The next thing we need to do is actually to pass our pandas data frame into this object and specify which tab of the Excel file we want it to be saved to. So to do that, we do final data frame dot to Excel, and then the first thing we pass in is that writer object. The next thing we pass in is the name of the tab we want it to be saved to, so we'll say recommended trades again. And the last thing we pass in is an index equals false argument. All right, so our object has been created. The next thing we need to do is to create the formats we need for our XLSX file. Now, earlier when I said that this library can be confusing or complicated to new users, this is where it gets really, really complicated. Formatting Excel files with XLSX writer is a science, and there's a lot to it, but I'm gonna try to keep things simple here, and hopefully you guys won't run into any hiccups. The first things we're going to do is create, I guess, two variables that specify the color scheme for our Excel sheet. And then we will reference those variables in all of the formats that we create later on, so that if we want to change one color, it will be reflected across all the different formats that we create later, instead of hard coding them in and having to change many different instances of a specific color. So specifically what we're going to create is a background color variable and a font color variable. So background color, and these are just going to be empty strings for now. Font color. All right, so what goes in here? These actually store the HTML hex codes for the colors that we want to select. So I'm going to use two colors that kind of match the style of the Free Code Camp website. I really like it. It's command line chic and very modern. So we're just going to follow that to make things easy. The background color is going to be 0A0 A23, and the font color is going to be F6F. All right, so that's that. Now we need to actually create a few different formats that we will be referencing when we actually apply the formats to our cells of our Excel sheet later on. So as you can see up here, we need a string format, a dollar format with decimals, a dollar format without decimals, and an integer format. So let's start with string format, and then what we're going to do here is create a writer.book.add format method. Inside this add format method, we have to create a dictionary, and this dictionary specifies the format of the cells that are going to have this applied to them later. So what goes in here? There's three main attributes: font color, background color, and border. Now each of these should actually be strings, and I'm going to fix that indenting issue. Since this is a dictionary, what is going on? I find the indenting on Jupyter Notebooks leaves a lot to be desired. Since this is a dictionary, these should be strings, and we have to add colons to each one. All right, so the font color is going to be font color, and this font color variable is what we defined up here. This background color is going to be background color, and this border is going to be 1. This just means to add a solid border around each one. Now, this is our first one. Let's run this code to make sure it works properly. Awesome. Now we need to basically template off of this and create a few other formats. So we have string format, and then we need to name the other ones that we described before this code cell. Say string format, dollar format, and integer format. Now, all of these are going to share the same attributes that the string format specified. We just need to add a few things to each one. So for dollar format, we need to specify a number format attribute like this. And the way that this works is actually pretty easy. You just pass in a number with zeros in it, templated the way that you want it to be formatted. So in this case, it will look like that. And then we will do the same thing for the integer format. So num format, and then we're just going to say 0. Awesome. Let's run this code cell to make sure there's no syntax errors. Excellent. All right, so now we need to apply the formats that we just created to our XLSX file, and this is like a bit complicated. So what I did here was I actually provided an example, and we can kind of use this to template on for all of the columns in our sheet. So what we need to do is say writer.sheets and then parse out the recommended trade sheet from that object. And then we use the set column method on that item to specify information about the column we're doing. Now, we're going to do this one by one first, and then we're going to kind of put everything into a loop because it'll be a bit more efficient on code and much more readable. So let's start with column A. You actually can't just put A, you have to put A through A like that. So that tells you the column, and then we need to specify the column width. Let's do 18 pixels. And then you need to say which format you want to apply to it. Column A is our ticker format, so we need string format. It's not a number. Now, if you run that, it returns 0, and that basically tells you that it ran properly. The way to actually see this in action is you need to actually save your writer object. Now, to do that, you say writer.save. And then if you go to your working directory where you're running through this, you should be able to open up your recommended trades Excel file and see that the first column has actually been formatted properly. So let's do that for all the other columns, and then we can change a couple things to make it formatted better. So how to do this? We'll just copy this a few times and change the letter 4 times to be specific. So this should be B through B, this should be C through C, and this should be D through D. Now let's run this and see what happens to the Excel sheet. Huh, only one was formatted. Why is that? Oh, I think we have to go back here and reinitialize this. All right, let's try now. Awesome. So as you can see, the columns are being formatted properly, but the headers aren't. Just so you know, we're going to solve that later. It's not something that I'm ignoring, but we will solve that in a few cells. So what we need to do now is we're going to simplify this by making 2 loops. And each of those loops is going to work with this column formats dictionary that we're going to create. So let's create column formats and make a dictionary. Now, what this dictionary is going to be is it's going to have a key for each column. So A, B, C, and D. And the value for each column is going to be a list. Inside that list, the first item is going to be the title, and the second item is going to be which format we want to apply. Format. Right, so ticker string format, and then stock price, dollar format. Oh, need a comma there. Market capitalize. And the last one is going to be number of shares to buy and integer format. So let's run that. So that cell ran correctly, which tells you that that dictionary is formatted properly. And now we're ready to start building a couple loops to do all of the work that we did up here, but automatically. So the loop that we're going to be building specifically is going to loop through every key in that dictionary. So we're going to say for column in column formats.keys. If you've never used the keys method to iterate through a dictionary before, it basically just returns all of these. So if you print the column, it should print A, B, C, D. Yep. Now what we need to do is create a writer.sheets recommended trades.set column. We're basically doing all the work we did up here. So set column. Here we're going to do an F string that interpolates in column. So this would just be like, for column A, would be A colon A. We're going to end that string. And then we're going to do 18 pixels wide. And then we're going to do column formats at column. So this will be this dictionary at key A. So this would return this list. And then we need the second element of this list. And since Python is 0 index, we parse 1. Great. So that runs properly. Awesome. So if we redo all of this to, okay, here's what we're going to do. We're going to comment out this. We're going to put a writer.save method there. Oops. And then we're going to go back to the start, reinitialize our writer object, and run all of this code. Awesome. Let's take a look and see what our Excel file looks like. Great, so everything's being formatted properly. In that loop, our code is a lot cleaner, it's easier to read, it's a big improvement. Now what we need to do is handle these. And columns in XLSX Writer are kind of hard to deal with. What I always do is I just overwrite them. So writer.sheets recommended trades, and then I do .write. And this write method, you pass in what information you want stored in the cell and what format you want applied to that cell. You also need to specify the location of the cell. So here's what we're going to do. We're going to do A1. We're going to say ticker, and we're going to say string format. Now, if we go back to the top again, reinitialize this and run through the rest of this, and go back to our Excel file. The first cell is formatted properly. So now we just need to do the same thing for stock price, market capitalization, and number of shares to buy. Let's go back. The easiest way to handle that is to just copy and paste. So this will change to A1, B1. No, sorry, that should be A1 or sorry, A2 or B1? Yeah, B1. Okay, perfect. All right, A1, B1, C1, D1. And then this will be stock price with dollar format. This will be market capitalization with dollar format. And this will be number of shares to buy with integer format. All right, as before, we're going to go back to the top. We're going to reinitialize this Excel Writer object, run our code to the very end, and then take another look at our Excel file. Awesome, so everything looks formatted properly. The only thing that might be worth improving is to widen this a little bit. But I mean, anyone who has an auto formatter for Excel will be able to handle that pretty easily. All right, so this violates the programming principle of do not repeat yourself. This is very, very loopable. So we're going to create another loop here that basically does this logic. So all right, so we're going to add this in here. And what we need to do is say column here and convert this to an F string. So as this loops through, this will go from A1 to B1 to C1 to D1. And then we need to capture this value here. So it's going to be column formats. So this is the dictionary. And then we parse out column. So this is the value of a key value pair. And then we want 0. And this will be the first entry of the list. So that is the value in the key value pair. So that's this. And then this needs to get replaced with the second entry of the list. Easiest way to do that is to just copy this and replace the 0 with a 1. So let's go there, 1. All right, as before, we're going to scroll all the way up to the top, reinitialize our writer object, move all the way through to the end. Let's open this up and see if everything looks okay. Great, so this is the final output of the first project from this algorithmic trading in Python course. It says here that the last step is to save the writer output. That's actually this line, so we're already done. And just like that, you've built your first algorithmic trading project in Python. I hope you had fun. The next two projects are going to be even more awesome, and you're going to learn a lot more. So I hope you enjoy the rest of this course, and kudos to you for sticking through it so far. All right, so welcome to the second project for this course, where we're going to build a quantitative momentum strategy. What we need to do to start, just like before, is we need to open up our Jupyter Notebook. So I'm here in my terminal in my home root directory, and what I need to do is navigate into my dev folder. And within that dev folder, I need to navigate into algorithmic trading in Python, which you can see here auto-completed for me. So we'll move into there. And now that we're here, we need to activate our virtual environment. So you'll remember from before that the command to do that is source and then venv/bin/activate. If you look to the left of your terminal command here, you can see that that venv in parentheses there shows that the virtual environment has been activated correctly. And now that the virtual environment has been activated, you can launch it with python-m notebook. That will launch your Jupyter Notebook. Now, one thing that I'm not sure I mentioned before is that you can deactivate a virtual environment by simply typing deactivate. And if you try to launch your Jupyter Notebook without this, it will actually fail because it'll say no module name notebook. So we need to reactivate our virtual environment and then launch our Jupyter Notebook. This will start the server in our browser, and we can get started. Just like before, we're going to want to navigate into starter files and then open up the second project this time, which is quantitative momentum strategy. So let's open that to get started. All right, so just like before, this Jupyter Notebook starts with a bit of background information. So it says, momentum investing means investing in the stocks that have increased in price the most. For this project, we're going to build an investing strategy that selects the 50 stocks with the highest price momentum. From there, we will calculate recommended trades for an equal weight portfolio of these stocks. So this project will combine a lot of the stuff that we used in the last section, so that repetition will help you remember what we actually just did, because I know that that last project actually contained a lot of stuff. And then we're going to build on top of that by not just equal weighting a already selected universe of stocks, being the S&P 500, but we're going to actually select a subset of those stocks based on their momentum characteristics. So let's get started by first importing some libraries. All right, so just like before, we're going to need NumPy, and we're going to import that as NP. We're going to need Pandas, and we're going to import that as PD. So as a quick recap, NumPy is the best Python library for numerical computing, and Pandas is a data science library that makes it very easy to work with tabular data in Python. You'll remember that we worked a bunch with the pd.data frame structure in the last project, and we'll do the same thing in this project. We're also going to need the requests library for making HTTP requests. We're going to need the math library for performing some basic math functions. And we're going to need the SciPy library. Actually, we're not going to need the whole library. We're just going to need the stats library from SciPy import stats. And the last thing that we need is the XLSX writer library, which we saw in the last section, allows us to easily format and save Excel files from a Python script. Now, we've seen all of these before except for the SciPy stats module, and what this does is it makes it very easy to calculate percentile scores. So we'll see later on in this project that what we're actually going to do is we're going to gather and parse momentum metrics for all of the stocks in our universe, and then we're going to calculate percentile scores for those momentum metrics. Then we're going to rank the stocks on those percentile scores, and we're going to select the 50 stocks that have the highest average percentile score across a broad basket of momentum metrics. So if you haven't seen SciPy stats, it's pretty easy. We're just going to use the percentile score calculation feature of it, and yeah, so that's it for our libraries. Let's move on to importing our list of stocks. So actually, we should run this code cell first. All right, so now that our imports have been done for our open source Python libraries, we need to actually import our list of stocks. Now, we also need to import our API token. We did both of these steps in the last project as well. So before I actually code this out, try to go through and, without looking at your last one, figure out how to import your list of stocks into a Pandas series and figure out how to import your API token for your secrets file. So cut here and try to do that before proceeding. Okay, I hope you had success doing that. If you didn't, the command to import your list of stocks is read .csv, and then type in your list of stocks. Now, this should autocomplete if you just type in SP, and then you can print it out to make sure it looks okay. Just like before, it has all 505 stocks in the S&P 500. And then for the secrets file, we want from secrets import, and if you hit tab, you can see that the IEX Cloud API token actually shows up here. So that is great. We can run this code cell to get both of those imported, and we can move on to make our first API call. Now, this is where this project will start to be quite a bit different than the last project that we worked through, because we're actually going to be pulling different stock market information from the IEX Cloud API. More specifically, instead of trying to pull price and market capitalization, we're going to be pulling price and 1-year stock returns. So to do that, we're going to go to the IEX Cloud docs. Oops, let's try and keep this all in one browser window. There we go. So IEX Cloud docs, and we're going to go here. It's usually the first non-ad entry in a Google search. And then we're going to run a Control F and see what kind of return metrics we can actually find in here. Okay, so return is clearly not a good thing to search for because it gives 341 hits, and you can see why that is. It's because a lot of these will say most endpoints return. So the fact that endpoints can return something and stocks can also return a percentage is not good. What if we just type in momentum? These are all more complex momentum metrics than we need. Okay, what if we type in price return? 0. What if we type in price return with no space? Okay, what if we type in year return? This might give us an API endpoint that gives us a 1-year return or something like that. Still nothing. What if we do performance? Okay, this gives us 21 hits. Sector performance. As you can see, it's not always super straightforward on how to find these. Okay. So now I'm searching through return again. It is a lot of hits, but I feel like it's going to be near the top of this documentation page. Okay, so this looks promising. This is a historical prices endpoint, and this would actually allow you to get the job done. You could pull in historical prices for, let's say, 1 year and use the today's price divided by the price 1 year ago and then subtract 1, and that would give you your 1-year price return. However, I know that IEX actually calculates this metric in a separate endpoint, so we're going to keep moving through this until we find it. Alright, so I had to cut there. It turns out what we're actually looking for is the word change, not the word return. And I do a control F, it's the first thing we find, of course. So this is the key stats endpoint, which you can get with the stats keyword in the URL. And if you look down here, there's actually an awesome group of momentum metrics. So you can do maximum percent change, 5-year percent change, 2-year percent change, 1 year, year to date, 6 months, 3 months. In case you can't see this, I'll zoom in a little bit. Oh, I guess you can't zoom. Oh yeah, there we go. Oof. That's a lot of zoom. There we go. There we go. All right, so max change, 5-year, 2-year, 1 year, year to date, 6 months, 3 months, 1 month, 3 days, 30 days, and 5 days. So this is the stats endpoint. What we're going to do is we're going to copy this, and we're just going to put it in our Jupyter notebook for now to come back to later. And we also need the sandbox base API endpoint. I'm going to zoom back to normal zoom because it's a little easier for me to navigate. All right, so here's the testing sandbox. We're going to find that this is the base URL. We're going to put this in here, right here. And then remember from last time, we need to actually include stable here. So this is a example of the base URL that we need to hit with our API call. We're going to call this string API_URL. And then we actually need to specify a symbol. So just like before, we're going to use Apple as an example symbol. And we're going to use an F string to interpolate that symbol variable into this. We can take this right off the end because we're not actually trying to parse a specific stat. And then we can use the requests library to make an easy API call to get this data. So to do that, we're going to say data is equal to requests.get, and then we're going to do API_URL, and then we're going to print the status code of that HTTP request to make sure that it went through properly. So this gives 400. We did something wrong. What is it? Sandbox.iex. Oh, we didn't pass on our IEX cloud API token, so we need to do $token equals IEX, and then tab, it should autocomplete. Try that. All right, so it returns 200, which means the API call is working properly. Let's transform this into a JSON and print this again. All right, so as you can see, this contains all the information that it should contain. The information that we specifically want is the 1-year price returns for every stock in the universe. So to do that, it's actually quite easy. We're going to cover that next. So to parse a JSON object like this, we saw in the last section that you just pass in square brackets and then the key of the dictionary. So the key that we want now is 1 year change percent, and all of these keys generally don't start with integers, they start with letters, so that's why it says year 5 instead of 5 year and etc. But this is the key we want, so we're going to copy this, we're going to move down here, we're going to add that in, and then this should give us 1.42. So what does that mean? That means that Apple has increased in price 142% in the last year, which is pretty impressive. It means that the stock has more than doubled, but I guess that's what happens when you sell a lot of expensive iPhones. So just like before, we're going to kind of loop through all of the stocks in our universe and provide API calls for all of them. Instead of looping through them one by one like we saw in the last section, which is extremely slow, we're going to move right on to executing batch API calls because that's kind of a better practice, and there's no point practicing executing single API calls when you'll generally never do that in practice. So the first thing we need to do is chunk our list of stocks into groups of 100 using the chunks function that we created last time. So to make this easy, I've actually included a bunch of reusable code from the last project here. So just run this code cell. That will give us the chunks function, and then we use the chunks function to divide our list of stocks into symbol groups of length 100. Then we create an empty list called symbol strings, and then for every 100 stocks in this symbol groups list, we create a comma separated list of strings and then add them to this symbol strings variable. So if you go through every symbol string in that list, we did this last project as well, but we're going to do it again just for practice, and then you print it, you'll see that this is basically just 5 lists, and oh sorry, this should be 4 in. Yeah, so this is just 5 lists of length 100. So, and when I say lists, they're not Python lists, they're actually strings separated by commas, but there's 5 of them. So here's one, here's another, here's where the 3rd one ends, the 4th one, the 5th one, and I said there's 5, there's actually 6, sorry. And that's because we have this short one of length 5 at the end. Okay, so that's all of this. I'm going to delete this out. And we are going to move on to creating a blank pandas data frame. So just like before, we're going to call this final data frame, and we're going to instantiate it by saying pd.dataframe and then columns equals, and then you'll see up in this code cell I've actually defined the names of the columns we want here. So it's ticker, price, 1 year price return, and number of shares to buy. These are basically the same column names as we used in the last project, except market capitalization has been replaced by 1 year price return here. So we can go down here and specify those columns by saying columns equals my_columns, and then if we print this, we should see an empty pandas data frame with the columns we specified. Awesome, so that's good. We're going to delete that, and then we need to loop through all of our symbol strings in the symbol strings object and create a batch API call. So for symbol string in symbol strings, and then we want to create a batch API call URL. We're going to leave that as an empty string for a moment. And then we want to create a data variable, and that's going to be a requests.get method that accepts batch API call URL and then calls the JSON method on it to transform it from a requests object to a JSON object. So what goes in here? Let's go back to the IEX Cloud docs to look at batch API call syntax again. Alright, so I just did a Control F for batch here to find this section, which tells you everything you need to know about batch requests. So stock, and then symbol, and then batch. Actually, we want to query, so this syntax here is for querying multiple endpoints for one stock, but we want to query one endpoint for multiple stocks. So we actually want to use this syntax here. So I'm going to copy this link address, and I think this just gives us the last bit. No, it gives us the entire thing. We're going to want to change this to sandbox because by default the docs give you a live URL, not a sandbox URL. And then we're going to want to move down here and change a few things here. So what endpoint do we need first? Actually, to start, move this up here so you can actually see it. To start, let's take off this last parameter and the range parameter, so those can both be gone. And then we're going to have to add back our token equals, and then IEX Cloud, oh sorry, this isn't an F string, so that won't autocomplete. IEX Cloud Yep, IX Cloud API token. And then we're going to want to change the endpoints next. So what goes there? Let's scroll back up to see which endpoint we actually queried earlier. All right, so we use the stats endpoint. So let's put that down into our batch API call, stats, and then here we want to change our symbols to be an interpolated variable that matches whatever the incrementer is of our for loop. So that is symbol string. All right, so now what we need to do is we're going to run over this loop once just to make sure that we're getting a 200 HTTP code to make sure that the HTTP request is being executed properly. So to do that, we're going to print data.status code. And for this to actually work properly, we're going to have to remove this JSON method temporarily from the HTTP request. And then here where we're specifying what we loop over, we're going to want to change this to a :1, which tells this to loop only over the first entry of that string. So if this is working properly, we will get a response of 200. Awesome, so that's good. We can get rid of this status code attribute from the data object and call this JSON method on it to see what the structure of the HTTP response actually looks like. So this is basically a huge dictionary. It has many levels. So at the top level, there is a key for this ticker and a value of a dictionary. And then within that dictionary, there is a key for the endpoint stats and a dictionary for the value. And then within that dictionary, there's a key for every metric with a value that corresponds to that metric. So we have to do multiple levels of parsing here, but before we do that, we actually have to loop over all of the stocks. So let's build that loop first. What we're going to do is we're going to say for symbol in symbol string dot split, and we're going to split on the colon character, which separates all of the tickers in the symbol string. So let's see what that split method actually returns before we go any further. Copy that, comment that out, and then print that. Oops. Print that. No. Print this is what I want to print. There we go. Awesome. So let's run that and see what it gives us. As you can see, this is a Python list where each item in the list is a symbol that corresponds to all the comma-separated symbols in the symbol string. Okay, perfect. So we'll get rid of this. Oof, did not mean to open my DevTools. We will uncomment this, and then we will start parsing the data in this loop. So we're going to say, so what we want to do here is we want to, for every ticker in this list, we want to append the relevant metrics to the final data frame. So to do that, we're going to say final data frame is equal to final data frame dot append. And then within this append method, there's a few things we need. We need a pandas series, and that pandas series will accept a Python list, and it will also accept the index equals my underscore columns argument. As you'll recall from the first project, this tells the append method where to actually put the new metrics in the existing pandas data frame. And then outside the pandas series, we're going to actually add ignore index equals true. Okay, perfect. So this is where we want to do our parsing. The first metric we want is symbol. The second metric we want is price. So to get price, we're going to need to do data, and then parse the symbol, and then parse the stats endpoint. And then we're going to have to actually see what the name of the price metric is within this. So let's, right here, let's just print out one example of this. Oh, sorry, not right there, right here. Let's print data, and then we'll use Apple as an example ticker, and then we'll use stats, and then let's just see what this gives us. All right, this is giving us an error because we didn't actually format the rest of it properly, but let's look and see here what we have for price. I'm going to do Control F for price and see if anything highlights up here. Market cap employees. Doesn't look like this actually has any price data, so we need to add here to our endpoints. We're going to say price and stats. Let's see what that gives us. If we parse price, I think this just gives us, yeah, $504. Okay, perfect. So this is what we need to do for price. We're going to replace Apple with symbol that we're looping over. And then we're also going to pass in 1 year price return. So we can use this print statement up here to see what we need. We're getting an error here because we're trying to append 2 values to a data frame that has 4 values. So for now, I'm just going to put in NA placeholders for both of them. And actually, for the number of shares to buy, that NA placeholder is actually going to stick. So we only need to figure out the 1 year price return. So we'll run this to get rid of that error and then look in here to see what we need to parse out for the 1 year price return. All right. Year 1 is what we need to search for. Okay, here's the metric. Year 1 change percent. So we'll copy that. We will paste that there for now. And then what we want to do is copy this, paste it there, and then add this in as an additional level of parsing to that. All right, let's run this. I'm going to take this off. And this means that instead of looping over just the first symbol string, we're going to loop over all of the symbol strings. And then outside of this big loop, I'm going to print the final data frame so we can see what it looks like. With any luck, this should be okay. Oh, I'm sorry, I'm going to do this again and remove this print statement. All right. Float object is not subscriptable. That's because we need to change this endpoint to stats, not price. All right, so this will take a sec to run. It's a pretty big data frame to build. Awesome, everything looks good. So just to recap, what we did here was we created an empty pandas data frame with the columns that are specified here, and then we looped over all of the symbol strings in our symbol strings object. We created a batch API call URL for those symbol strings that hits 2 different endpoints. It hits the price endpoint and it hits the stats endpoint. And then we use the requests library to execute an HTTP request to get that data in the form of a JSON object. For every string in that comma-separated string of for every symbol in that comma-separated string of symbols, we split them using the split method to get a list of them, and then we looped over that list to append the data for each symbol to our empty pandas data frame. And then we printed the pandas data frame, and it looks like this. Everything seems to be working so far, so we can move on to removing low momentum stocks from our pandas data frame. All right, so like the other code cells in this project, this has a bit of background information. It says the investment strategy that we're building seeks to identify the 50 highest momentum stocks in the S&P 500. Because of this, the next thing we need to do is remove all the stocks in our data frame that fall below this momentum threshold. To do that, we'll sort the pandas data frame by 1 year price return and then drop all stocks outside the top 50. That sounds easy enough, and pandas actually makes it very easy to sort data within the data frame. So we're going to use some built-in functionality of the pandas library to do this. All right, so the first thing we're going to do is call final data frame, and then on this final data frame, we're going to call the pandas method that allows us to sort the data frame based on values contained in its columns, and that method is sort values. Now, this takes a few different parameters. The first one is the column that you want to use to sort. So we're going to use 1 year price return. If you just type in 1 and then tab, it might autocomplete. Now, if it doesn't autocomplete, you can just go up here and copy it. Copying is always a good idea because there's lots of different ways you could spell this, and it's just kind of avoids any typos, although typos are a pretty easy bug to fix. All right, so 1 year price return. And then the next parameter it accepts is whether or not you want it to sort ascending or sort by descending. Now, we want to sort descending values so that the highest momentum stocks are at the top. So to do that, we'll say ascending equals false. And then the last thing we want to say is in place equals true. Now, if you've worked with pandas lots in the past, you're definitely familiar with this in place equals true method. What this does is it changes the function from just returning a sorted data frame to actually modifying the original data frame. Now, to see this in action, you can take it away, run this, and it shows the highest 1 year price return stocks at the top. But then if you run that line and then print the original data frame right below it, it will not return the sorted data frame, it will just return the original one. So this shows you that without the in place equals true method, it doesn't actually modify the original data frame. Now, if you add the in place equals true method, that's not true, it will return the sorted data frame. So that's how we sort the values. Now what we need to do is modify the pandas data frame so that it only includes the first 50 rows. Now to do that, it's actually quite easy. You can just pass in the dash 50, colon 50 specification into square brackets like this. Now, the indices are all different now because it's been sorted. So I'm actually going to just make sure that this is right by doing length. Yeah, so it's 50. Great, so this has 50 stocks now. And then to make this so that it actually modifies the original pandas data frame, all you need to do is say final data frame equals, final data frame equals 50. And now if you print it, it will just return a data frame with 50 rows. Awesome. So one last thing that we can do is to reset the index so it doesn't start and have kind of this random list of numbers. So the easiest way to do that is just with pandas reset underscore index method. It doesn't actually accept any parameters, but as you can see, it does the job. Now, just like before, without the in place equals true method, this doesn't actually modify the original data frame, so we'll have to specify that in here. You'll notice as you work more and more with the pandas library that this in place equals true parameter works in almost all of the functions that you use regularly in the library. So there we go. So just to recap what we did here, we took our final data frame object, which contains price and momentum data on all the stocks in the S&P 500, and we sorted its rows based on their 1-year price return such that the highest momentum stocks are at the top. And then we use the in place equals true parameter to actually modify the original data frame instead of just returning a temporary copy. Once that was done, in the next line we modified the data frame such that it only contains the 50 stocks with the highest price momentum. And then we used pandas reset underscore index method to change the index of the data frame so that it actually runs from 0 to 49, or 0 to 50 I should say. 0 to 49? Yeah, 0 to 49. And then we just printed out the final data frame on the last line. So with that out of the way, we can move on to actually calculating the number of shares to buy for this simple momentum strategy. All right, so just like in the last project, this is going to be kind of similar. The only change we're going to make is that we're going to wrap the functionality of accepting the portfolio size inside of a function, because we'll actually be using the same functionality later in this tutorial when we build a better and more robust momentum strategy. You can actually see that heading here. We start it in the next code cell. So to do that, we're going to have to wrap it in a function, and it's probably not necessary to wrap it in a function. You could just copy paste code. It is a Jupyter notebook after all, but it is definitely better to create functions if you're ever going to reuse any code. And since we're not building too many functions in this Python course, it's kind of a good excuse to practice building Python functions. So if you're familiar with Python functions, and since we've already done this same functionality in the last project, try to pause this video here and try to complete the function yourself without watching me code through it. So break now and try that yourself. All right, so what we're going to do is we're going to say def portfolio underscore size. So if you're not familiar with function syntax in Python, this is just defining a new function called portfolio size, and the empty brackets here means that it accepts no parameters. And then the first thing we're going to do is we need to create a global variable in here, so this function can define a variable and then it can be accessed outside that function. So the keyword to do that is global, and we're going to call this variable portfolio underscore size. And then what we're going to do is we're going to say portfolio underscore size is equal to input, and then just like before, we're going to say enter the size of your portfolio. Now, as we saw in the last project, we need to make some special functionality here such that if someone tries to enter a string into this Python input, it will tell them to re-enter a float value. So what we're going to do is we're going to say try float portfolio underscore size, and if this returns an error, we're going to say print that is not a number. And then we're going to print again and say please try again. And then we are going to say basically this exact same functionality. Great, and then the only other change we need to make is to actually specialize this accept statement so that it only works on the certain type of error that would happen if someone entered a string into this. So that type of error is a value error, so we'll do that here. And actually, now that I look at this, this is a bit unnecessary with two separate print statements, so I'm going to copy this here and do a new line character and try that. Okay. So let's run this to see if it defines properly. Awesome, it does. So we're going to use this portfolio size function to accept a portfolio size now, and then we're going to use it again later to accept a portfolio size for our better and more realistic momentum strategy. So now we're going to make sure this works. And actually, before we proceed, one thing that's worth noting is that this function should be called portfolio input. And it doesn't actually have to be called portfolio input, but it definitely should not be called portfolio size, because then it has the same name as this variable. And that's kind of an easy way to introduce logical bugs into your code, is by having a function and a variable with the same name. So we're going to change this to portfolio input, and then we're going to run this code cell to define it. Then we're going to test it by running portfolio underscore input. And then we are going to print portfolio underscore size. Now, here it's especially important to print the variable that's defined inside the function, because we need to make sure that this global keyword is working properly. So let's run this and see what happens. So enter the size of your portfolio. We'll enter $1,000 and it should print $1,000. Awesome. Now let's try this again, but put in a string. So we'll say my portfolio is too small to matter to you. That's kind of sad, but we're going to try it. And then it says that is not a number. Please try again. Okay, so my portfolio is 1. Awesome. So our portfolio input function is working properly. We can now move on to looping through our pandas data frame and calculating the number of shares to buy. So the first thing we need to do is actually calculate our position size, and to do that I'm going to actually enter a slightly larger portfolio. So we're going to say that's 1,000, that's 1,000,000, let's do 10 million. And what we need to do is calculate position size. So to calculate position size, we're going to do position size is equal to float of portfolio size divided by the length of our pandas data frame. So we'll say length of final data frame, and then you can take the length of any column. I usually do dot index for this. So this gives us, let's print it out to see what the position size is. This gives us, is that 200,000? Yep, 200,000. And that makes sense because we're just doing 10 million divided by 50, so that kind of math checks out. And then the next thing to do is we need to loop through all of the rows in the pandas data frame. So for that, we're going to say for I in range 0, and then the length of the data frame, final data frame. And then let's just print I to see what happens. So this goes from 0 to 49. And if we go back up to our pandas data frame, we can see that the last index is 49 and the first index is 0. So that's awesome. That looks like it should work properly. Let's take away this print statement now, and we're going to loop through all of the entries within the number of shares to buy column. Now, the way to do that is with pandas LOC functionality. We're going to pass in I for the row, and we're going to pass in number of shares to buy for the column. Now, what we want to do here is just make sure that we're accessing this properly. So we're going to say 0, and then at the bottom we're going to say final underscore data frame. Now, if this works properly, what should happen is every entry in the column of number of shares to buy should be replaced with a 0. So let's try this. Awesome. Now we're getting a warning here because it's saying, I think this is actually a bug with pandas, although I'm not sure, this setting with copy warning. It's because it says if value is trying to be set on a copy of a slice from a data frame, try using .loc equals value instead, and that's kind of exactly what we're doing. So I'm not really sure what's going on here, but you can definitely ignore that for now. So now what we need to do is calculate actually how many shares to buy. So to do that, we're going to have to access the price column of the data frame, and we're going to have to divide the position size by that price. So first we'll take position size, and then we will divide it by this LOC method, but instead of number of shares to buy, we're just going to replace it with price. Now let's run this and see what happens. Awesome. So as you can see, this is giving us fractional shares for everything, and like we talked about in the last section of this course, we don't want fractional shares for this. So the last thing we need to do is wrap all of this in a math.floor function. Oops. And this will round every number in this number of shares to buy column to the lowest closest integer. So let's try that. Awesome. It's looking good. I think we are ready to proceed to building our better and more realistic momentum strategy. So let's do that now. All right, so it's time for us to build a better and more realistic quantitative momentum strategy. Now, what does it mean for a momentum strategy to be better? There's a lot of different ways you could define it. Obviously, a strategy is better if it performs better, but it's kind of hard to tell that without foresight. So what I mean by building a better momentum strategy is that real-world quantitative investment firms typically differentiate between high-quality momentum stocks and low-quality momentum stocks. So a high-quality momentum stock is a stock that over a long period of time shows slow and steady price returns. So, if a stock returns 0.5% every month for a year, that would be kind of like a high quality, slow and steady momentum stock. A low quality momentum stock might not show any momentum for a long period of time and then surge upwards over a short period of time. So if you have a stock that returns 0% for 11 months and then 10% in 1 month, that would be considered a low quality momentum stock, even though its 1 year price return would be 10% and might be better than a lot of other stocks. So it might be hard to tell why that definition of high quality versus low quality momentum stocks is important, but the reason why is because you want stocks that are seeing price returns in reaction to slow and steady business progress, not one-time business news. So the example that I used here is I said the reason why high quality momentum stocks are preferred is because low quality momentum can often be caused by short-term news that is unlikely to be repeated in the future, like an FDA drug approval for a biotechnology company. So this kind of begs the question, how do you identify high quality momentum stocks? And the best way to do it is to take a basket of different time series momentum metrics and use them all when calculating which momentum stocks to include in your strategy. So to identify high quality momentum, we're going to build a quantitative momentum strategy that selects stocks that have the highest percentiles of 1 month price return, 3 month price returns, 6 months price returns, and 1 year price returns. And we're going to call this our high quality momentum strategy. So you'll see that I use the abbreviation of HQM fairly often, and that stands for high quality momentum. Let's start by building our data frame. So the first thing we need to do is actually specify our columns. This is going to be a much longer Python list than what we used in the past for columns because it's going to include so many more metrics. So the first thing we're going to use is ticker, and then price, and then number of shares to buy. We're going to have to create a bunch of slots for our return metrics and our percentile metrics. So to give you like a broad overview, we're going to fill in one column for each time period that has how much that stock has returned in the last year. And then right beside that column, there's going to be another column that has the percentile score of that return relative to all of the other stocks in the universe. So we're going to do 1 year price return, 1 year return percentile, and then 6 month price return, and then 6 month return percentile, and then what's the next one? 3 months? Yeah, 3 month price return, and then 3 month return percentile, and then 1 month price return, and 1 month return percentile. All right, let's run this just to make sure it's formatted properly. Awesome. So now we can create our data frame, which is going to be HQM data frame is equal to pd.dataframe. And we're going to specify columns equals HQM underscore columns. Awesome. Now let's print this HQM data frame to make sure that it is an empty pandas data frame with the columns that we specified. Awesome. Now we can start looping over our symbol string object that we created earlier for symbol string in symbol strings. And here's where we have to create our batch API calls and do kind of all the similar logic that we used before. So the first thing we're going to do is execute our batch API call. So we can actually use very similar logic to that as before. So we're going to scroll up here, find our old batch API call, and use the same logic because we don't actually need any metrics that weren't included in this. So we'll copy both of these lines. So what we're grabbing here is the batch API call URL and the HTTP request that grabs the JSON object from that URL and stores it in our Python script. So we'll scroll back down to where we were here, and we're going to add this to this loop. All right, and now we need to loop through all of the symbols in that symbol string. So we're going to do for symbol in symbol underscore string dot split on the comma character, just like before. And then in here, we need to parse out all of these metrics. So whenever I'm doing high-level parsing like this, I find that it's easiest to just literally copy this in, and then you can replace each metric with what you need. So this is going to be an append method first. HQM underscore data frame is equal to HQM underscore data frame dot append. And then in here, we have to pass in all the things that we've been using throughout this course. So first it'll be a pandas series, and inside that pandas series, there'll be a Python list. We'll fill that in later. And then we have to say index equals HQM underscore columns. And then here we have to add the special ignore index equals true. All right, let's move back inside this Python list. We're going to paste those metrics, and then I'm just going to get the indentation looking a little better here. So I'll do that. All right, so one easy thing we can do is all of the percentile metrics we're just going to fill in to start with NA, and we will loop back through all of those metrics and use the SciPy library to calculate their percentile scores later. All right, so that's easy. Ticker will be replaced by symbol, which is the incrementer of the for loop that we're in here. Price will be replaced by the price metric, the price endpoint from the iCloud API. So to do that, we're going to say data, and then symbol, and then price. Awesome. The number of shares to buy, just like before, will be filled in with an NA placeholder. And the 1 year price return, we actually already parsed out in our last example. So we can just go back up and copy that down to our new high quality momentum strategy. All right, so here's the original parsing of the 1 year price return. We can copy that, scroll back down to where we were. Sorry, right here. All right, and we will replace this with the parsing of the equivalent metric. Awesome. And then, as you can see here, we are just going to copy this down to all of the other price returns and then change them to fit. So this is month 6 instead of year 1. And then we'll copy this and move it down to here. And this will be month 3 instead of month 6. And this will be month 1 instead of month 3. All right, so let's run this to see if it works, and then I'll do a quick recap of everything we did in that cell. So there's invalid syntax here. Oh, there's a missing comma there. Let's try this again. Length of past values is 11, index implies 10. What's going on? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we were missing a comma here, and if we run this now, it should work. All right, so that is running correctly, it looks like. We're going to run this again and print out the final data, or sorry, it's not the final data frame anymore, it's the HQM data frame. And see what happens. All right, so this is a big data frame, quite a bit bigger than the ones we worked with in the past. It has ticker, price, number of shares to buy, 1 year price return, 1 year return percentile, 6 month price return, 6 month return percentile, 3 month price return, 3 month return percentile, 1 month price return, and 1 month return percentile. So we have lots left to do to this data frame, but first we're going to go through to each of these percentile columns, and we're going to replace these NA values with a percentile score that shows how high a company's momentum is for that time period relative to all the other stocks in the universe. So this is where we're going to do this at. There's going to be a lot of repeated logic in this section, so I find the easiest way to do this is to create an array called time periods, and then inside this array we're going to create a string for each time period that we're going to be looping over, and then we can use string interpolation to make this much easier. So we're basically going to say our time periods are 1 year and 6 months and 3 months and 1 month. Now, if it's not exactly clear yet how we're going to be using this, what we're going to do is we're going to loop through all of our columns and replace this value with a value from this list so that we have to write the logic once, but we can actually use a loop to calculate the percentile scores for all of the percentile columns. So that's kind of what we're doing here. Now, the next thing to do is create the actual loop. So for row in hqm.dataframe.index, and then we need to use another loop inside of this. This inner loop is going to loop over the time periods object that we just created. So for time period in time periods, and then here we're going to use the pandas LOC method to change the value of each time period column. So we're going to say hqm dataframe.loc. The row is going to be this row incrementer that we're looping over here, and then the column is going to be we're going to make an f string here, and we're going to say it's going to look something like this with an interpolated value in it. So let's copy that. We will put that in here, and then this is the time period that we want to interpolate. So we will, oh, and just so you know, you've probably seen me do this quite a few times in this course. All that I'm doing there is I highlight the string, and then I do I enter the curly bracket character. So I just enter that character, and it will automatically wrap whatever you have highlighted in those curly brackets. It's quite a nice little feature. Okay, so we're going to replace this with time period, and then what we want to do is assign that to something. So to start, let's just try assigning them all to 0, and then, oops, didn't mean to edit that. And then at the end of this code cell, we will print hqm_dataframe. Let's see what happens. All right, so you can see all the percentile scores are being replaced with 0, which is awesome. But that's not quite exactly what we need to do yet. We need to actually use the SciPy stats module to calculate the percentile score based on whatever's inside of this. So let's do that now. The function we're going to use is stats.percentile of score, and then how this function works is it takes two arguments. The first argument is the entire column, and then the second argument is an entry from that column. So to start, we're going to need the column, which is simply hqm_dataframe. I'm going to scroll this up to make sure you can see it. And then we need to pass in this string. Sorry, not that string. We need to pass in this string as the column name, and then interpolate in the time period. So it will look like this. Awesome. Now, what we need to do next is interpolate in the time period value. So we need to change this to an f string, and then change this to time period. All right, the last thing we need to do is put a comma here and add in the actual value that we want to calculate. So what we're going to do is use the LOC method. I'm going to copy this and put it in as a placeholder, and then all I have to do is change the column name to match this. Now, I know that this is a really long Python line. We're going to refactor it in a second, so just hang tight. So copy that and put that in here. All right, looks like I got some duplicate F's in parentheses. Okay, let's try this. All right, so these look quite good. You can see that Apple, which has one of the highest percentile scores for 1 year, has one of the highest momentum scores for 1 year, has a 99th percentile, so that's good. Everything here looks pretty logical to me. So what we're going to do now is refactor this code so it's much more readable. So first thing we're going to do is we're going to say change change column equals something, and percentile call is equal to something. The percentile column is this. So we can copy that and replace this with this. And the return column is this. Or the change column, I mean, sorry. All right, so let's go back through and replace these. Oops. And we'll go down here and replace this with the same thing. Okay, this is quite a bit more readable. I'll scroll up so you can see what I actually did here. So basically this is saying we're going to take the HQM data frame, and at row of row, and in the percentile column, we're going to assign it to this calculation, stats.percentile of score, and then we're going to call this HQM underscore data frame at change call. So this is the column that we're using to base our percentile calculations on, and this is the entry from that column whose percentile score we want to calculate. Now, one other thing that we could do to this is we could say change this import somehow. So if we go back to the top and we say copy this and move up to here, and from SciPy import stats, and then we could say, okay, so percentile of score is what we want. Stats import percentile of score as score. Okay, so what this is, if we run this import now, so we're saying from SciPy's stats module, import the percentile of score function as score. So we can go down and erase that very long function call and just type score instead. And all those changes will make this much more readable. It means you won't have to scroll horizontally to actually see the entire line. Just so you know, in Python and most software development, it's kind of considered a bad practice to have really long lines. So if you can break it up like this, it's much more readable and much better. Oh, I think I deleted too much. Take this. All right, so that almost fits on one line now. It's still quite a long call, but if we run this now, it should have all the same functionality. Great, so now we can move on to actually calculating the HQM score. Now, we haven't actually talked about the HQM score yet, so let's do that now. The HQM score is just going to be an arithmetic mean of all the percentile scores for the momentum returns that we calculated in the last section. So to do that, we're going to import the mean function from Python's built-in statistics module. So we're going to say from statistics import mean. Let's run that to see if it works properly. Now, the way the mean function works is you can just say like a few numbers in here. What's the mean of 2 and 6? Well, this should be 4. And mean takes one position. Oh, sorry, this has to be a list in here. Yeah, so that's kind of how the mean function works. It's kind of exactly what you'd expect. We're going to use that to calculate the average of all of the percentile scores that we calculated in the last section of this project. And we actually have to do this row by row. So the first thing to do is to create a loop. We've been using lots of loops in here, but it's good practice. So for row in HQM data frame dot index, and then the first thing we're going to do is create a empty Python list called momentum percentiles, and then we're going to loop through all of the appropriate columns in the data frame to get the momentum score for that row. So let's first do momentum percentiles equals empty Python list, and then we need to loop through all of the time periods in the time period object that we created earlier. So for time period in time periods, and then we need to append the momentum scores to this momentum percentiles list. So momentum percentiles dot append, and then in here we want to say an LOC method on the HQM data frame, HQM underscore data frame dot LOC. The first entry will be the row, the second entry will be an F string, and inside that F string we are going to say time period and then return percentile. All right, let's try this just once and see if we actually get a reasonable momentum percentiles object. Print. All right, so we get 85, 85, 62, 35. Let's go up here and see if that looks right. 85, 85, 62, and 35. Awesome. So now what we can do is calculate the mean, and we're going to put that mean in the HQM score column. Now, looking at this in hindsight, we don't actually have an HQM score column, do we? What we're going to do now is go back up to the top and add our HQM score to our columns. So first add this to this column. For now, it's going to be an NA placeholder, just like all of these were. HQM score.